Some dinosaurs, discovered back in the late 1800s and early 1900s, have become so iconic and well recognized that they have firmly made a name for themselves in popular culture across the world. It is commonplace to see the face of a Tyrannosaurus rex, for example, plastered across children's toys, birthday cards, video games, and movies, alongside the uber-famous Triceratops, stegosaurus, and brachiosaurus. However, is this starting to change? Since these early discoveries permeated popular culture, hundreds of new dinosaur genera have become known to science, and some of them have been around just long enough to start breaking through to the general public's consciousness and understanding about dinosaurs. Think of some of the more modern classics when it comes to dinosaur genera. Therizinosaurus, with its iconic claws. Spinosaurus, with its immense size and bizarre body shape. Argentinosaurus, as one of the largest living things that has ever lived. And now, the latest addition to this amazing squad of iconic extinct reptiles is Carnotaurus, otherwise known as the meat-eating bull. You might recognize this strange South American Abelisaurid from recent entries into the Jurassic World franchise, or even the first series of Apple TV's Prehistoric Planet, which aired in 2022. With the classic form and power of a large theropod, this dinosaur possesses a few other features that make it stand out from the crowd. Bull-like horns atop its skull, and comically tiny arms that would make even the Tyrannosaurids take pity. There is a lot more to the story of Carnotaurus than just its appearance in popular media, however, and today we will be exploring this dinosaur in great detail. We will be taking a look at how the genera was discovered and named, what it looked like in life, where it lived, and how it behaved. Sit back and relax as we travel back to prehistoric South America to meet one of the major new faces of paleontology, Carnotaurus. Carnotaurus saustrii, the sole species of the Carnotaurus genus, was a large yet lightly built predatory theropod dinosaur that existed in what is now the country of Argentina in South America from around 71 million years ago to around 69 million years ago. The time this dinosaur was alive was known as the Maastrichtian stage of the late Cretaceous period, the very final point in the Mesozoic era that saw the eventual end of the dinosaurs when a huge meteor came crashing down to Earth in the Gulf of Mexico. Of all the predatory dinosaurs known from the Southern Hemisphere, and certainly from South America, Carnotaurus is the best known, despite paleontologists having only recovered one skeleton from the depths of the Earth. Carnotaurus was an Abelisaurid and a member of the clade Pherulusauria within the Abelisaurid family. Abelisaurids, as we will discover later, were one of the main groups of predatory dinosaurs alive throughout the Cretaceous period, all of which were present on Gondwana. Gondwana was the name of a huge supercontinent present in the world during the Cretaceous, which was effectively a combination of many landmasses we know today, including South America, Africa, the Indian subcontinent, Madagascar, and both Australia and New Zealand. Gondwana would eventually break up and spread itself out across the southern hemisphere in the following Cenozoic era, to form what we know as nearly half of the land on our planet today. Like all theropods, Carnotaurus was a bipedal dinosaur and fed exclusively on meat. The one skeleton known to science shows an individual dinosaur that was between 7.5 to 8 meters in length, which, compared against the other members of the Abelisaurid family, puts Carnotaurus as one of its largest members. Unlike many of the common large theropods that roamed across the Cretaceous world, Carnotaurus seemed to be a particularly specialized dinosaur, whose body had evolved a number of unique features and capabilities to suit a more narrowed-down lifestyle than that of its contemporaries. We will go into much more detail on these features later on in the video, but perhaps most noticeable out of all Carnotaurus's adaptations were its cranial horns and tiny arms, two features that were missing to such a degree on almost every other carnivorous dinosaur ever to evolve. Looking at a living Carnotaurus, the first thing you would notice is its impressive skull structure. The skull in total measured around 60 centimeters in length, from the tip of the snout to the point it connected with the neck. It was a short, deep skull with a broad snout, giving the overall head a blunt appearance, drastically different from many other Cretaceous predators. The impressive horns, roughly 15 centimeters each in length, jutted out from above the eyes, thick and sharp, not unlike a modern-day juvenile goat. These horns were made of bone and were extremely tough. It has been suggested, in years as early as 1990, that this was not the full picture of Carnotaurus's skulls. These bones may have served as attachment points for even bigger layers of keratin, meaning that this dinosaur's horns could have taken on many shapes and sizes. Perhaps they spread out horizontally from either flank of the skull, or perhaps they were curved downwards, like that of a modern-day bull. Either way, if this theory is correct, Carnotaurus would have been a fearsome sight, one that few contemporary dinosaurs of this time were able to intimidate. What was the purpose of these horns, however? Scientists seem to believe that these horns were used in potentially violent displays, or competitions to win over a mate, or drive an intruder out of the territory. A Carnotaurus with strong, powerful horns would be able to use them in an emergency, perhaps swinging at the flanks of opposing dinosaurs, or delivering thrashing blows to the head or neck. Potentially, the sight of the horns alone would have been enough to force an intruder or rival to back down. While they were lightly built, these dinosaurs were impressively powerful, and a physical fight could have been costly for both sides. The teeth of Carnotaurus were relatively broad, spaced closely together in the mouth, a relatively new discovery after it was determined in 2020 that the teeth on the original skeleton had been damaged and misidentified as slender, lengthy structures. 16 larger teeth lined each side of the upper jaw, whilst 15 shorter ones were packed into the bottom jaw. It was the upper jaw that gave the skull its characteristic short, deep form. It formed the main part of the dinosaur's skull. The lower jaw, on the other hand, was thin and tapering against the wedge-like upper. The differences in sizes of the jaws does not mean that the dinosaur had a weak bite force. Quite the opposite, in fact. Loose connections in sections of the skull meant that this dinosaur could open its mouth wide, and the jaw was very flexible, able to deliver swift and powerful bites. The skull was followed by 10 neck vertebrae, 12 dorsal vertebrae, and 6 sacral vertebrae, and an undetermined number of tail vertebrae. The dinosaur would have held its body straight, and its neck was thick and tough. It is thought, due to the size of the bones present in this region, that there would have been plenty of room for powerful neck muscles on Carnotaurus, which adds to the theory that these dinosaurs could have engaged in dramatic sparring matches with their horns. The second most noticeable feature of this dinosaur in life would have been, without a doubt, its arms, or lack thereof in terms of size. In relation to the size of its body, Carnotaurus was the owner of the smallest arms of any carnivorous dinosaur. These relatively tiny structures were dwarfed by even the arms of the Tyrannosaurs, whose small frontal limbs are relatively the subject of discussion and even jokes. The arms of the Carnotaurus would have resembled nothing more than stubby tubes jutting out from the shoulders, with a forearm just a measly quarter of the size of the upper arm. While the arm possessed 4 digits, only the central 2 of them extended into external fingers. The 4th finger may have created a spur or stub on the side of the dinosaur's hand, whilst the 1st digit was essentially non-existent on the outside of the animal. The dinosaur could not move these fingers at all, and they may not have even ended in claws. It is thought that Carnotaurus's limbs may have been vestigial, essentially meaning that they have been reduced by evolution to the absolute minimum, given their lack of particular need or use in the animal's lifestyle. Given a few more million years, perhaps Carnotaurus's descendants may have reduced their forelimbs even further into an even more atrophied state. This can be seen in some modern bird species. The cassowaries, emus, and kiwis of Oceania and Southeast Asia almost lack wings entirely, reduced to tiny forelimbs tipped with wiry feather structures due to a lack of use after the birds evolved to become flightless. Another thought is that these limbs did retain one function: display of all things. There is always the chance that these structures were eye-catching or brightly colored in order to attract the attention of a mate. Perhaps the dinosaur would frantically wave its arms in the air to create a dazzling display of contrasted color in order to reel in the attention of a possible partner. Carnotaurus is so well known to science as a result of the condition of the sole skeleton scientists have uncovered. Not only was this nearly complete skeleton dug up in almost perfect condition, but we even have evidence of fossilized skin segments in the rocks it was discovered in. From studying the impressions in the rocks, paleontologists have been able to determine that the skin of Carnotaurus was rough and highly textured. Patches of grooves, bumps, cracks, and openings imply that the dinosaur was covered in a mosaic-like structure of flat scales, not unlike those found on modern-day crocodile or alligator. These scales did not overlap and seemed to vary across the entire body. In some regions, the skin was embedded with holes and spikes, with large scales placed closely together In others, there was more of a pattern dominated by grooves and pits, with smaller, more seemingly incoherent scales. It is thought that across the dinosaur's body, some of these scales may have adapted into scutes, used for defensive purposes when deep in combat with members of the same species. With all these highly attuned structures and features combined, Carnotaurus was a powerful predator. As one of the largest animals in the regions it occupied, it likely would have taken on very large prey items. These included large herbivores, perhaps even those as large as the sauropods that traveled in herds across ancient South America. A bite from the full weight of Carnotaurus's jaws could have weighed in at a force of just over 7,000 newtons, meaning that repeated attacks on large animals were enough to deal some serious damage to potential prey. Modern hyenas, lions, and tigers, while certainly not boasting the most powerful bite forces in the animal kingdom, managed to bring their prey down with bite forces of around 4,500 newtons. While it would have been outmatched by crocodiles and some sharks, Carnotaurus could still inflict devastating wounds on its prey with just its teeth alone. Some theories even claim that the theropod used its upper jaw, teeth included, like a club, opening its mouth and slamming the jaw tooth first down onto its victim. Conversely, there is also a running theory that due to the relatively smaller bite force exerted by Carnotaurus, it may not have preyed upon large animals at all, but instead chased smaller creatures through the undergrowth. Instead of tearing off chunks of flesh, it would have perhaps consumed small mammals and reptiles in one swift motion. The former theory, as it stands, looks more likely to be true, and it is still thought that Carnotaurus aggressively hunted large animals. Recent analysis of Carnotaurus shows a surprising fact. It was perhaps one of the fastest predatory dinosaurs known across the entire Mesozoic. The research to determine this was undertaken by looking at Carnotaurus's leg bones and the muscle attachment points alongside them. The dinosaur as a whole was thought to weigh around 2,000 pounds, only 4 times that of a modern-day lion. For a large predatory theropod dinosaur, it was lightly built and did not have much weighing it down when it came to running after prey. The caudofemoralis muscles, located on the thighs of the dinosaur, would have weighed around 300 pounds in total. When the scientists took into consideration the size, weight, and positioning of the animal's tail in relation to its body, the relative light weight of the dinosaur's body, and the force that could be exerted by the leg muscles, it was decided that Carnotaurus could run through the forests and coastlines of its ancient Argentinian home at speeds abnormally high for a large predator. While it would not have been as swift and agile as its distant dromaeosaur and ornithomimid cousins, it would have been able to chase down its prey at considerable speeds, making it an especially efficient hunter. As you now know, only one specimen of Carnotaurus austrii has ever been discovered, and it is almost immaculately preserved. It was discovered by a team led by José Bonaparte, an accomplished and famous Argentinian paleontologist, famous for his work on the dinosaurs of South America. He and his team unearthed the iconic theropod in 1984 on the same expedition that would introduce a Margosaurus, a species of bizarre sauropod, to the world. The expedition was sponsored by the National Geographic Society and had previously seen Bonaparte and his team depart to the wilds of Argentina 7 times before to look for vertebrates from the Jurassic and Cretaceous periods from South America. Of all places, it was in fact a farm that concealed the skeleton below the earth. Not too far from Bajada Moreno, in Argentina's Chubut province, the skeleton laid in wait for around 70 million years before the first human beings would lay eyes on it, embedded deep within a very tough hematite concretion. It took Jose and his team a long time to carefully extract the bones from the rock. But eventually, Carnotaurus was shown to the world the following year, in 1985. Carnotaurus translates into English as flesh bull, which has helped to develop the dinosaur's nickname, the meat-eating bull. This species name, Saustraei, was given to thank the owner of the farm, Angel Saustre, on which the fossil was discovered. The degree of preservation and the fact that the skeleton is almost complete has led to Carnotaurus being one of the most well-understood theropods, and by far the most well-understood Abelisaurid. The fossil stands proudly on display today in the Argentine Museum of Natural History in Buenos Aires, Argentina, where it has remained since its discovery. Casts and sculptures based on this skeleton can be seen in several more museums around the world. The skeleton dug up by Jose Bonaparte and his team is thought to only be missing some sections of the tail and hind legs, which were destroyed due to weathering over the millennia in which the dinosaur came to be buried in the earth. It belongs to an adult Carnotaurus, with the fused joints in the brain case being used as evidence to propose this. At the time of discovery, it was found laying on its right side, with the head and neck splayed out across the back of the torso, a typical pose seen in many theropods who have been preserved well enough in prehistoric rocks. While it was a very lucky find, and was indeed preserved well, some elements of the skull have been warped and pushed around over time, meaning that scientists have had to figure out the complete structure of this dinosaur's face and head over time. We have used the phrase Abelisaurid multiple times in this video now. But what exactly was one, and what made Carnotaurus one? Abelisaurids were a group of large and powerful theropod dinosaurs, all of which were carnivorous, that lived throughout the Cretaceous period on the supercontinent of Gondwana. The very first of the Abelisaurids appear in the fossil record towards the end of the Jurassic period, and teeth that are thought to have belonged to an Abelisaurid have been uncovered in Portugal, but these are exceptions to the trends. The very last of the Abelisaurids appear to have been wiped out with the rest of the dinosaurs in the catastrophic end Cretaceous extinction event, meaning that some members of the Carnotaurus family were amongst the very last species of dinosaur to die out. Carnotaurus, however, is thought to have become extinct 3 million years before the catastrophic end of the Mesozoic era. Abelisaurids were generally stockily built dinosaurs, with extravagant and ornamented skulls. The skin on these dinosaurs, or the surfaces of the bones themselves, were often rough and grooved, racked with osteoderms and scutes, used for defensive or offensive purposes. They were large, yet not as large as many species of other large carnivores, such as Tyrannosaurus or Spinosaurids, measuring typically between 5 and 9 meters in length, from the tip of the snout to the tip of the tail. Although it is possible that an unnamed species from Kenya may have reached as long as 12 meters altogether. The hind limbs are, in fact, a great way for scientists to identify whether or not their dinosaur is an Abelisaurid. Many of these dinosaurs feature fused upper ankle bones connected to both each other and the tibia bone in the leg. Abelisaur tibias are shorter than their fibulas, which give off the characteristic stocky build of these dinosaurs. 3 digits were present on each foot, with an extra one that did not make contact with the ground. Many Abelisaur skulls, like that seen in Carnotaurus, were deep and short, some of which were nearly as tall as they were long, and many of these skulls featured the classic grooves and pits seen across much of the typical Abelisaur body. All Abelisaurs had small forelimbs, yet none were quite as reduced as those belonging to Carnotaurus. Abelisaurids were most commonly found across South America and Africa, with more isolated populations in India and Oceania. Over their wide range, they evolved into many awe-inspiring forms. Huge theropods, unlike anything alive today. Elsewhere in South America, for example, lived Ilocalesia, a dinosaur known from Argentina's Huinco Formation, also known for harboring the mighty sauropod Argentinosaurus. The continent formation is also known for Scorpio venador, a Crixinatosaurus, and Abelisaurus itself, all of which, while not as well known as the infamous Carnotaurus, were equally impressive, powerful animals that hunted their own large prey items in their own regions. Africa saw the rise of Abelisaurs taking over as some of the continent's top predators throughout the Cretaceous. The most famous of these dinosaurs was Majungasaurus, from the island of Madagascar. It lived right through to the very end of the late Cretaceous, and remarkably, is known from remains that contain bite wounds from what could potentially be a member of its own species, making it one of the only dinosaurs thought to have practiced cannibalism. Asia, specifically what would eventually become the Indian subcontinent, is known for a slew of impressive Abelisaurids. Amongst them was the 6-meter-long Brachiosaurus, a forest-dwelling apex predator, and Indosaurus, a poorly known and mysterious genus of Abelisaur that was first discovered in 1933. Other fearsome faces in the Abelisaurid family include Rugops, Aucasaurus, and Eobelisaurus. Carnotaurus was first unearthed in the rocks of Argentina's La Colonia Formation, where it acted as the apex predator for the region it inhabited. The La Colonia Formation in the late Cretaceous was a lush coastal forested environment, full of greenery and crystal clear blue waters, Many of the plants known from La Colonia Formation were aquatic, representing a mixture of both angiosperms, or flowering plants, and gymnosperms, or seed-producing plants. On top of this were multiple pteridophyte plants, which are known to produce spores, not flowers or seeds. Many of the latter would have littered the forest floor in the forms of horsetails and ferns, while huge conifers towered above the landscape, occasionally split by clearings in the woodland and large open areas by the water's edge. It would have been an area of great natural diversity and beauty, packed with color and life. The animals of the La Colonia Formation, like many fossil sites across the Mesozoic era, are represented most richly by reptiles, and not just dinosaurs. Along the waterways and coastlines of ancient Argentina would have lived various species of extinct turtle, perhaps ripe for the picking for passing carnivores such as Carnotaurus and its young. Some species from the La Colonia Formation represent side-necked turtles, such as Yaminocheles, a representative from a currently extant group containing some of the strangest reptiles alive today. Many modern side-necked turtles boast long, slender, flexible necks, making them quite unlike many other species in their family. And this ancient ancestor was likely very similar. Elsewhere lived Patagonia emes, a type of stem turtle that would have looked much like modern-day terrapins or pond turtles found in today's waterways. As Carnotaurus patrolled the coastlines of its lush green home, it might have occasionally spotted a great splash in its peripheral vision out at sea, caused by a great reptile breaching the surface of the water. This would have been a brief glimpse of a plesiosaur, the Cretaceous counterpart to the seals and dolphins that hunt fish in the seas of modern times. Of the two named species known to have inhabited the waters of the La Colonia Formation, Sulcasuchus was a smaller representative, with a shorter neck and a longer, more slender snout, perfect for darting in and out of shoals of fish to snap up individuals from within, whilst Kawanectes, at 3 meters long, was much more traditional in shape. With its long neck, it would not have needed to entirely immerse itself within a shoal of fish, and could rather spend much of its time poking its neck into the frenzy to pick out 1 or 2 at a time. The presence of such large marine predators indicates that, just off the coastline of the La Colonia Formation, a whole other world of wildlife darted and swept through reefs and rock formations. The La Colonia Formation is known for its dinosaur life too, but surprisingly the only dinosaur from the area that has been named and described is our Carnotaurus. Carnotaurus was not the only Abelisaurid present in the region, and the other species is known from a quite complete skeleton, but is yet to receive a name or description. An ankylosaur is known from the region, but only from one single osteoderm embedded in a nondescript Argentinian rock. This is not enough information for scientists to reliably describe it, and as it stands, this dinosaur is nameless. It shares this fact with an undescribed titanosaur, known from 2 vertebrae fragments and 2 metatarsal foot bones from an undetermined theropod. Alongside these is an unknown hadrosauroid, known from a few vertebral fragments. We may have a long way to go before the La Colonia Formation's dinosaur life is shown to us in full Technicolor, but we know from the plant life and existing animals of the region that this is likely just scratching the surface on what this ancient land has to offer. Moreover, the La Colonia Formation was something of a stronghold for prehistoric mammal species. Many mammals across the Mesozoic era would have been small and unobtrusive shrew-like creatures. Hard to spot, yes, but by no means boring. These animals would have been biding their time over the millennia, living in the shadows of giants such as Carnotaurus, ready to strike when their time was right. As soon as the asteroid hit, the mammals could begin their ascent to the throne, blossoming into all sorts of new and strange shapes, as yet unseen in nature at the time. While over 300 individual mammal specimens are known from the La Colonia Formation, these discoveries only typically come from 3 distinct species. Amongst the leaf litter of the forest floor lived Argentinosaurus coloniensis, Regatherium bonodontum, and Coloniatherium selinskii. It is thought that these mammals may have been multituberculates, named for their additional growths present on their teeth. Multituberculates made up the majority of mammals found throughout the Mesozoic era, and had just begun to diversify into more and more elaborate forms as the dinosaurs began to thin in numbers towards the end of the Cretaceous. By the end of the era, some of these animals had begun to evolve from their lives of living timidly in the undergrowth. Some of them took to the water, while some favored the trees. Many could be found in deserts, while some favored mountainous habitats. A select few even became predators, hunting members of their own kind, just as the dinosaurs had been doing for millions of years prior. Their glory days were yet to arrive, but these little mammals were well on their way to success. Over recent years, Carnotaurus has been depicted in more and more pieces of popular media concerning dinosaurs. The biggest of these, unsurprisingly, has been the Jurassic World franchise. You might think, based on our other videos that mention this often scientifically flawed series of films, that the producers of the movies would have got the dinosaur completely wrong. But the Carnotaurus to feature in the second installment of the trilogy, Fallen Kingdom, seemed to create a good reconstruction of the South American Abelisaurid. The horns were there, the tiny arms were there, the dinosaur was supported by a long, tapering tail, and the skull formation was just about accurate. The only difference between the movie model and the real-life dinosaur was the dinosaur's body structure. Real-life Carnotaurus was likely more slender and less stocky than the dinosaurs shown in the film. But given the fact that this is near enough the most accurate dinosaur portrayed by the series, it is only a very minor error. It can also be said that Carnotaurus stole the show in 2022's Prehistoric Planet, an amazing and accurate documentary developed for Apple TV, narrated by the legendary Sir David Attenborough. Carnotaurus was featured in the Forests episode of the 5-part series, where a male was shown building a nest-like structure in a verdant green clearing. He is approached by a female, who he then attempts to win over in a spectacularly bizarre mating display. Raising his tail and alternating the stomping of his feet, he repeatedly throws his body back and waves his tiny arms around in a circle, which are shown to be an electric blue color on the underside. This is speculation based on science and modern animal behavior, of course, but it made for an excellent and endearing part of an already spectacular television show. So that was a rundown of the life, discovery, and evolution of Carnotaurus, one of the most spectacular dinosaurs ever to live. Carnotaurus is a testament to the diversity and specialization of dinosaurs across the Mesozoic period. At face value, it may have seemed that many large theropods all adopted similar body plans. But taking a closer look at atypical dinosaurs, such as this South American Abelisaur, can show us that these animals were extremely different. Moreover, it is very refreshing to see some newer, stranger genera of dinosaur taking the limelight in recent years. As amazing as icons such as Tyrannosaurus were, the theropod world is full of wonders waiting to be discovered.